Alright, hello, this is Miss Goodwin. Welcome to Objective 2.2.2, Interior and Exterior Angles. This is a continuation of the last video you should have watched. And the objective is that we can prove the angle sum theorem and use it to find the sum of interior angles of any polygon. So, first things first, let's recall that the angle sum theorem says that all angles in a triangle add up to 180 degrees, as pictured here. So that is given to us, but how can we use that to help us with other polygons? Let's look at this shape right here. This is what we call a quadrilateral. Or a square or a rectangle. But in general, four-sided shapes are quadrilaterals. And I just answered the next question. We have four sides. Now we need to see how many triangles we can make. So you're going to start at one point. I'm just going to pick point A. And connect it to every other vertex. So we don't need to connect it to B or D because it's already done for us. But we can connect it to C. And I can see we have 2 triangles. Now each triangle is 180 degrees. We have 2 triangles. So to find a total sum of the interior angles of this quadrilateral, we are going to take 180 and multiply that by 2. 180 for the triangles, 2 for 2 triangles, which gives us 360 degrees. Okay, let's try another one. Now we have a pentagon. It's a little lopsided, but we're going to do the same thing. Let's start from some point A, connect it to every vertex. We don't need to connect it there. Connect it here, connect it here, and here. We don't need to, but there we go. And we have 1, 2, 3 triangles. So we have 5 sides, 3 triangles. And we could do the same thing. So 180 degrees for the triangles times 3 gives us 540 degrees. Let's see another one. Start here at point A. Connect it to every vertex. Oops. The line's not cooperating, but hopefully you get the picture. So we have 1, 2, 3, 4 triangles, 6 sides, 4 triangles. We get 180 times 4, which gives us 720 degrees. Now, do you notice any patterns so far? Think about it for a second. Notice that for every side we gain 1 more triangle. So, for example, with a quadrilateral, that is 1 more side than a triangle. So we get 1 more triangle. So for every new side, we get 1 more triangle. I also noticed that we always have 2 fewer triangles than sides. So for however many sides we have, we could subtract 2 from that, and that will give us how many triangles we got. So for example, we have 4 sides minus 2 triangles. That gives us 2. Here we have 5 sides minus 3 triangles, that gives us 2. 6 minus 4 equals 2, so on and so forth. So that is where this next formula comes in. This is the formula for the sum of interior angles. N minus 2 times 180. N is how many sides the polygon has. The minus 2 is how many triangles fit in the polygon. And the times 180 is how many degrees in a triangle. So we do the n minus 2 first, and then multiply that by 180. So let's find the sum of the interior angles for each polygon below. We have 1, 2, 3, 4 sides. So we could do 4 minus 2 times 180. Gives us 2 times 180, which is 360. Okay. Look right here at this pentagon. We get 1, 2, 3, 4, 5. So we got 5 minus 2 times 180. 3 times 180, which is 540. Okay. Go ahead, try the next. Pause the video and try the next two real quick. Okay. Now I'm going to go over them, so if you haven't tried them yet, pause it real quick. And here we go. 1, 2, 3, 4, 5, 6. We got 6 sides, so we do 6 minus 2 in parentheses times 180. Gives us 4 times 180, which gives us 720. And in the last one, we get 1, 2, 3, 4, 5, 6, 7. So we get 7 minus 2 times 180. That gives us 5 times 180, which is 900 degrees. Okay. So now, so far, we have found the sum of the interior angles for each polygon below. Interior means inside, so we found what all the inside angles add up to. Quick side note, if you want to figure out what each angle equals, you could just divide by however many sides we have. So if we do 360 divided by 4 sides, assuming they are all equal, then each angle will be 90 degrees. Obviously, this requires them all to be congruent angles, but same thing here. 720 divided by 6 equals 120. So if the hexagon has all congruent angles, they are all 120. Try the next two on your own. We got 540 divided by 5, and that gives 108 degrees. And then we got 900 divided by 7, which gives us a kind of nastier number at 128.57 degrees. Okay. And now that's for interior angles. Now what about exterior angles? An exterior angle is, let's say we have some shape, like a triangle. The exterior angles are the ones that go like this. So if we were to extend each side out, these are the exterior angles. Now, no matter the shape, they always equal 360 degrees. no matter the shape. It could be a triangle, square, hexagon, a shape with 100 sides. They always equal 360. So if you want to find the measure of one exterior angle, assuming it's a regular polygon with all congruent sides and angles, then you're going to do 360 divided by n, where n is sides, number of sides. So for example, with the square, we have 4 sides. So we do 360 divided by 4. Each exterior angle is 90 degrees. With a triangle, we got 3 sides. So 360 divided by 3 equals 120 degrees. Okay, try the next two on your own. Okay. You got 1, 2, 3, 4, 5 sides. 360 divided by 5 equals 72 degrees. And we have 1, 2, 3, 4, 5, 6 sides. So we got 360 over 6, which gives us 60 degrees. And that is for exterior angles, so the outside angles. So thank you for watching. Go ahead, summarize below, try and answer the question, how can we find the measure of angles in any polygon? Remember to tell apart interior and exterior angles because those are different and will give you a different answer. Go ahead, start the practice now, and I'll see you next time. Bye!